Do, 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 do. Mhm. So let's see if we can get even better.
Have you ever wanted to spawn thousands of game objects, but this happens? Well, throw out that outdated instantiate function and let me introduce GPU instancing, a way of rendering tens and thousands of game objects in mere milliseconds with frame rates above 120. GPU instancing works by sending the GPU a single mesh and its submeshes that need to be rendered using the graphics.pro mesh instance function. It also takes the material that you want to render the mesh with and an array of transform matrices that define the mesh's position, rotation, and scale in that order. That's actually all the parameters we need. Before I show you how they
Graphics draw. Draw mesh. Unity spawn.
Let's learn how to spawn objects in Unity. By the way, welcome to the channel where I cover game development content and tutorials. And if that's your thing, I hope to see you around. But let's get started. So I just have a simple scene right here. All I've done so far is just open a new default project, add in a plane, and then change the skybox for YouTube Pizzazz. But if we want to spawn an object, we must first have an object to spawn. So I'm just going to create a simple sphere for us to reuse. All I'm going to do here is add this orange material that I pre-created so the sphere is easier to see, and I'm going to add a rigid body component to the sphere so that it has physics and is impacted by gravity. And if I test this out real quick, you can see that when I hit play, the sphere has gravity and falls to the plane. Cool. Now, if we want to spawn this sphere multiple times in our scene, we need to tell Unity that this sphere is reusable and not a one-time thing. And we can do that by simply dragging it into our assets folder, which will immediately turn this into a prefab, which is reusable. Now we need to create the logic for our sphere, so I'm going to create a new game object to hold this logic, and I'm going to call it a spawner. On our spawner game object, I'm going to create a new script to write this logic, which for consistency's sake, I'm also going to name spawner. Now heading over to Visual Studio, I'm going to delete the start and update methods. I'm going to be testing our logic using a button, so I will not need them. But first, we need to tell Unity which object we want to spawn, so I'm going to create a public game object and name it my sphere that will hold the sphere that we just created in the Unity editor. Next, for the actual logic, we're going to create a function. It has to be public since we want to attach it to a button in the editor, and it's also going to be void since we're not returning any value. But the logic is pretty simple here. It's just instantiate and then passing through the variable that we just created, my sphere. But now our logic still doesn't know what my sphere is in the context of Unity, so this is where our prefab comes in. We can just drag and drop our sphere prefab into the slot.
Actually, what if I do this? I'm just curious here. More than anything, just curious. Okay, so first things first. We have 1,000. Sure, that works. I'm going to get rid of this because we don't need it anymore. This here, this is important here. This is what we're dealing with here, right? Can I rename this? Beautiful. Okie dokie. CPP naming. That's not at all what I wanted. Uh, C sharp naming. I don't really like this whole like everything starts with a capital thing. Oh wait a minute, no, this is public. Ooh. Unity naming. First letter is lowercase. Avoid single letters. Oh my god, I love that. How do I change this styling? Mm-hmm. Oh, here we go. Naming. Fence. Did I not do that right? Mm. Oh, is it this one? I thought it was this one. I want to say. I feel like it was this one. But instance fields. This one here, if I go like this and I do that, didn't fix it. Oh, wait. If I go back to this and I go like this and I do upper, if I do this and I do a prefix of m underscore, does that fix it? Um, it's still not liking it. Parameters. I guess we'll just deal with it for now.
Hello everyone, in this video
that we created, and we're good to go there. Now to actually test this logic, we need to create a button to call the function, which requires a canvas object. Now double click on that to see your whole canvas, and after we slide down to the on click section and click on where a case, you can see that let's test this one, it's just another way. Here, into the slot that we created, and we're good to go. We're going to create a pretty simple here, it's just in, so this is where, and then passing through the variable that we just created, my sphere. But now our logic still doesn't know what my sphere is in the context of Unity, so this is where our prefab comes in. We can just
Am I actually initiating like that? How am I initiating? I am initiating like that. I wonder if there's a different initiate Unity. I go to profile, right? And we hit play. There, we've initiated. GC Alec. GC Alec. Unity profiler. Enables call. One sec. Enables call stack for all managed memory allocations. Okay, so that's garbage collector, not graphics card. Still not bad considering it's only what one little thing, right? That's actually pretty good for, how we're doing there. Mm,
Hey, I'm Brandon. If you've been learning game development on YouTube for any length of time, you will inevitably end up asking the question, how is it handled in a commercial game? A lot of YouTube tutorials end up doing things very quickly or doing things just good enough, but they end up having this kind of game jam feel to them. And if you're anything like me, you want to know how to take that mechanic to the next level. How do actual real games handle these situations? In Samarado, the commercial game that my wife and I are working on right now, I just finished working through a problem where I needed to be able to spawn chests and enemies and various other things into the game, but I need them to 100% of the time never spawn on top of the player, on top of other enemies, or into the walls, or on top of other items. So you are going to learn how to do that right now. Ready? Let's go. So I kept this scene very simple to keep things on point. What I'm aiming to do is when I walk through this opening and enter this room, we'll spawn a few enemies into the room. And the rule's going to be they cannot spawn on top of other enemies, or in the wall, or on the player, and they have to spawn inside this room. So you can see I've just got this object which holds a few different box colliders, and we're combining them into one polygon collider with this composite collider here. And first, really quick, we need to be able to detect when the player enters this room so that we know when to spawn enemies in. And you can set this up in a dozen different ways. It really depends on your design needs, right? Do you have some high-level manager controlling what enemies get spawned into a room each time you enter the room, or do you want to control down at the room level? You could use scriptable objects to hold the spawn info, so you could have an object you control that way. So first, I'm going to create an empty game object called entrance inside of this room walls object. And let's add a box collider 2D and set it to trigger and place that at the entrance of the room. And let's create a script called room detection and add it to the entrance game object. So first, we're going to do this in an onTriggerExit2D function, and I don't want to search for a tag each time something collides with this trigger, so let's just store our player once in the start function, and now that way we can check if the collision game object is the player game object. And if it is, we want to make sure we're exiting from the correct side, right? I don't want to walk on here and exit from the left and then have things spawn into the room on the right. That makes no sense. So let's grab a reference to the collider on this game object and use that to calculate a direction. The formula to calculate a direction is simply destination minus origin normalized. You're going to want to get comfortable with that formula. You will use it a lot when making games. And in this case, destination would be the player's transform because the origin is definitely this game object's collider. Okay, so now we just check, is the x of the exit direction greater than 0? And if it is, then that means we did exit from the right and we should spawn in some enemies. Now, there are two pieces of information we're going to need to pass in. We want an array of enemies and a spawnable area. Depending on your project, this could be a box collider, a tile map collider, a composite collider, but it doesn't matter. The generic collider 2D will work for all of those. So let's just plug in a debug.log statement to make sure that that's working. So we hit it, nothing happens. We exit from the left, nothing happens. We exit from the right. There you go, cool. So now let's handle actually spawning the enemies in. Create an empty game object called enemy spawn manager, and let's also create a script called enemy spawn manager and attach it to that game object. First, let's make this a singleton, and we're going to want 3.
Wait, I was going to do something. I don't think this is what I was looking for. Yeah, it was not what I was looking
Hello
for.
everyone. In today's video, we will cover the new spawning system that is included in the latest update for the combat module. This is a feature I was personally really excited about, as I'm creating an open world game and this will be a game changer for performance. In order to do this, we will need Unity, Game Creator, and the combat module. Before we start, I would like to of course thank all of my Patreon supporters for the absolutely amazing support.
Wait, Unity Game Creator? What the fuck is that? Oh.
Okay, welcome to part
Mass Spawner.
2 of this tutorial series. And the last one we made the lights move around randomly. And now we're going to make a gate that is going to spawn the lights fast, and it's also going to kill them. So first of all, let's make the lights a bit smaller. It's going to light. You can just say scale, maybe make to 0.2. That looks okay. And then here we're going to apply to all the prefabs. Okay, you can delete it anyway. Now grab the sprite circle, drag it into the scene view, and that is going to be our gate. And the first component of our gate is going to be a script, which is going to be our light spawner. Light spawn. And since we are, let's also make another script. It's just going to be called light. And that one goes onto our light, of course. And it's going to be our way to keep track of the light. You don't see that right now when we open up the light spawn. Okay, in here, first of all, we need to know what we're actually going to spawn. So let's get the prefab. Let's make 0 as field. Say private game object, call it light prefab. We're going to assign that in the inspector. And we also would like to know how many lights we want. Once again, serialize it and make a private integer lights to spawn. Like so. And one more time. Yes. And a function that is going to do that. So let's say private void spawn. No, sorry. First of all, we're going to create the lights. And so we need a list to keep track of them. The light prefab is automatically.
No. Mm.
Have you ever wanted to spawn thousands of game objects, but this happens? Well, throughout that outdated instantiate function, and let me introduce GPU instancing, a way of rendering tens and thousands of game objects in memories that define the mesh's position, rotation, and scale in that order. That's actually all the parameters we need. Before I show you how the instancing works though, I want
Submesh index. Yeah, it's probably this.
the matrix type that Unity has is the data structure that the transform component uses to define the object's position, rotation, and scale. To create our own matrix 4x4, all we need to do is as follows. Create 3 vector series for position, rotation, and scale. Next, we create a local matrix variable called matrix, and we can set it equal to matrix 4x4.trs, short for translation, rotation, and scale. Then into the TRS function, we pass in our position.
Okay, wait. So so we're now aware that one of our big issues here is going to be what is this? Okay, yeah, so that's fine. One of our issues here is that we're not spawning them fast enough. So how fast could we theoretically spawn them if we were to do this, right? So let's do this. Now the problem is that I don't think
Position vector,
this
quaternion.u
works.
rotation.
Sorry, the thing is that I don't think that this, like, you have to handle the draw calls for this if you want to do it this way.
As the TRS function takes a quaternion to convert the rotation vector into a quaternion, we use the u function and the scale vector. So that's all the code we need to create the 4x4 matrix for any position, rotation, and scale that we want. Meshes in Unity have two arrays that define the composition, a vertex and a triangle array. The vertex array represents the positions of the vertices of the mesh, and the triangle array tells Unity the indices of the vertices that need to be connected up to form the collection of triangles used for rendering, lighting, and displaying the mesh. Meshes can also contain multiple submeshes. The more submeshes a mesh has, the worse it will perform with GPU instancing, so you have to keep instant meshes to only have one mesh or one submesh. The way meshes are rendered onto a screen is by using a material. The material allows a mesh to be rendered and defines the properties such as smoothness, color, and opacity. Different submeshes can have different materials, but one submesh cannot have more than one material used to render it. When we are instancing our object in the graphics.drawMesh instance function, we need to pass in the submesh index. If the mesh we want only has one submesh, the main mesh, then we can just keep the submesh index to 0. But if we have multiple submeshes, we need to render each one with a different material. That's why we will be creating a material array instead of a single material. Even though we will be using this method, I still recommend you only use one material and one submesh for instance objects. But without further ado, let's start coding. In a new C# script, you'll need to create a public int for the amount of instances you want, a public mesh variable for the mesh that you want to instance, a public material array for the materials you want to render each submesh with, a private 2D list of matrix 4x4s for the transformation of our instances. You can call this variable batches. The reason we need the 2D list instead of a normal list of matrices is as the graphics.drawMesh instance function can only render meshes in batches of 1,000. So say if we want 1,000 instances, we need to create 10 batches of 1,000 matrices. The way we will code GPU instancing is by creating our batches in a start function, and then every frame we will instance our meshes, allowing us to render them on screen. Let's start by creating the function to render the meshes, and then we will deal with the batches. To begin the rendering function, we'll create a new function called renderBatches and make it a private void. Then, inside this function, create a for each loop that goes through each batch in our 2D list like so. Now create a for loop inside that for each loop to go through each submesh in the mesh, using the mesh.submeshCount int. Finally, write the graphics.drawMesh instance function and pass the mesh that we want to render into it. We need to pass in the submesh index, so just add the I variable. For the material, we need to pass the material that corresponds to the submesh index. To do this, we just index the material array with the I variable. Finally, for the matrix 4x4 array, pass in the batch variable, which is just one of the matrix lists from the matrix array. That finishes the rendering function for the instancing.
I wonder if this would work. Because, like, we... Unity mass spawner. Instantiate prefab. In this article, I would like to explain two different functions that we always use to create objects in our project. Both functions seem to do the same thing. However, they actually have an important details that distinguish them. Let's start with the most common function, which is initiate. Initiate, the initiate function makes a copy of an object and returns the clone so that you can visualize the scale, position, and rotation, etc. of an object. The detailed information can be found in Unity scripting API because there is another point. I would like to draw attention to is initiate function does not preserve the prefab connection in other worlds. This method does not create prefab connection to the new instanced object. So what does that mean? What does that mean? Let's explain with an example. This is an example usage of this function below so that we can compare after I explain the other function. Var clone equals initiate clone object transform. Quaternion identify. Let's assume that we implement an editor and we create an object in editor time through this editor code. When we create the object, it loses the prefab instance connection. That means when we make any changes in the prefab, the object which is created on the scene is not affected by those changes. Imagine that you have a huge environment and that then you would like to change something, but you have already created or manually placed them. Unfortunately, you must change them one by one. This is actually a very difficult situation for projects that are often subject to change, such as mobile games that frequently are updated in small changes. So the alternative behavior. Okay. Hmm. Okay, so what if close that? Okay, what if we actually do this? No, not this one. Not this one. This one. What if we actually try this? Like how much faster could we get this to be? Since we're doing this anyways. Let's give it a try. Let's actually try this. Okay. Oh, we have the prefab right here, game object prefab, right? So what we want to do is we want to initiate the draw mesh. Let's try this out here. Now I don't think this is going to move any of them. So that kind of blows, but whatever. Oh, I know. Okay, wait. Instances mesh. I don't think that's the way to go. Because we're going to be moving them and whatnot, I don't think that the batching for using this is the right way to do it. Because that just does the draw, right? And I don't think that's really what we're looking for. Unity mass spawner. New objects and use the baker to attach an entity component. System ECS. Wait, what? That's not what we are looking for. I do wonder, what if we do this asynchronously? Unity async functions. Or sorry, synchronous function. No. Would it be burst?
Asynchronous programming allows you to execute multiple tasks at once without blocking the main thread. For example, while an episode loading data, the user should be still able to use it. It will also help you to chain events easily, so it can be used for cutscenes. It works similar to coroutines.
Oh, it was jobs. That's what I wanted to do.
Hey guys, welcome. My last few tutorials have been focused on performance, so to keep that trend going, this video is going to show you how to use the jobs system in Unity. Basically, it lets you easily write multi-threaded code for your game, and you can use the jobs system whether you have an ECS project or not.
Wait.
Hey guys, welcome. My last few tutorials have been focused on performance, so
Oh, okay. They're just similar enough that they initially looked this almost the same.
keep that trend going, this video is going to show you how to use the jobs system in Unity. Basically, it lets you easily write multi-threaded code for your game, and you can use the jobs system whether you have an ECS project or not, which is awesome. If you are new to the job system, then this video is perfect for you. Ready? Let's go. So in my scene, I've got this enemy spawner that will spawn 15,000 enemies into the scene when we hit play. And you can see they're looking at us every frame, and they like to keep their distance from us as well. And we're running this around 24 frames per second right now, which is not great. Here's the enemy we're spawning in. They have an enemy behavior script on them, meaning each individual enemy is controlling their own behavior. There's really nothing fancy going on in here. In update, we're just calculating and applying the rotation and moving their position if it's below the threshold. And we'll go through this code in detail in just a minute. Now the thing is, we can improve this even without jobs right now. Since mono behaviors come with some overhead, having 15,000 objects control their own movement behavior might not make the most sense. So I'm going to control their movement inside this enemy spawner script here. And that's going to be really easy to do since I'm adding them into a list as they're being spawned in. So now we have this nice list that we can loop over. So in update for all the enemies, first we need to calculate their looking direction, which is towards us, which is just the normalized distance between them and the player. Then we can turn this into an angle using @2, which returns radians, so this will turn it into degrees, and I'm subtracting 90 just to account for them by default pointing up instead of pointing right. Then we can use quaternion.angle axis to turn that angle into a look direction based on vector3.forward, which is just shorthand for 0 on the x, 0 on the y, and 1 on the z. Then apply that rotation. Okay, and then we'll adjust their position to move along the negative direction, multiplied by time.delta time, and move speed. But we're only going to do that if the distance between the player and the enemy is less than or equal to a threshold distance. Okay, so we were at about 24 frames per second with 15,000 mono behaviors, and now we're around 27 frames per second with one mono behavior controlling 15,000 game objects, which is still not great. So now let's use jobs to improve this even further. So what jobs will actually do is allow you to make use of multi-threading in your game. Basically, default C# code that you write in Unity runs on one thread called the main thread. But if you have a modern PC, then your CPU has multiple threads, and the other threads that are not the main thread are called worker threads. Jobs allows you to use both the main thread and the worker threads. And as complicated as that sounds, it's actually really easy to do, all things considered. You don't need to worry about which thread to use or anything like that, it's all managed for you. But it does require some setup on our part, so let's see what is involved in that. Modern versions of Unity will have Burst installed by default since it has dependencies in the engine now. We also need mathematics because Burst has an easier time with the mathematics library than the normal mathf library. I'm gonna get rid of this here because we'll need to rewrite.
Do I have mathematics installed? Oh yeah, I can uninstall Ruhanka now. I'm not going to use it for this. Wait, did I already do it? I think I already did it. No, it says it's in project. And there's nothing to do apparently. Okay. Interesting. Oh, here we go. Oh, yeah, yeah. These two are both these are these don't need to be here anymore. There we go.
Write it using the other math library to make it.
Right, fuck. I was looking for that. The math library. Okay, it's already there. Okay, sweet.
Compatible with Burst. Now for our purposes here, we need two namespaces. Unity.jobs, which is always required for jobs. And for whatever reason, the interface that I need is inside Unity engine.jobs, and I have no idea why there are two libraries, but anyways, we need to create a struct. You can do this in the class, outside the class, in its own script, whatever helps you stay organized the best. My preference is in the same script, but outside the class, so I'm going to do that. And we need to inherit from an interface. We have a few options here. iJob is if you want to schedule a single job, and you'll probably want to use that when your task does not involve iterating over a collection or a list of objects. iJob parallel 4 is when we do want to iterate over a collection or list and perform a task on each of those, which I could use here, but actually I want to directly change the transform of each enemy in this job, and using iJob parallel 4 transform, as the name suggests, makes that nice and easy to do. So we need to implement the interface member, and that'll give us this execute method with an index if you need it and a transform access. So this represents the position, rotation, and scale of an object. Now I'm going to add the burst compile attribute up here, as well as at the top of the class. Burst translates your C# or .NET code into a highly optimized native code, but it's strict and doesn't support all the types that normal C# does. So we're going to need to do our math using the mathematics library, which is actually really not that bad. It has almost all the same functions that mathf has, so it's going to feel pretty familiar to use. We're also going to need the collections library. So first, let's set up a couple of variables: our player's position, our delta time, distance threshold, and move speed. We're going to pass in all these values when we actually create a job in our update function, and I'm using the read-only attribute because by default native containers are read and write, which means you cannot schedule two jobs referencing the same containers at the same time, but by using this attribute it'll allow two jobs to run in parallel reading data from the same container. So first we want to calculate the direction, so we're returning a float 3 instead of a vector 3, but this should look familiar. We're normalizing the player's position minus the enemy transform.position. You'll notice our transform is referring to this transform access, not the usual transform. You can't access transform here like in a normal behavior. There's no way to use normal reference variables, but this one has some magic behind the scenes, so that's why we are using this. Calculating the angle and the look rotation should be extremely familiar. We can't use vector 3.forward, but this means the same thing. And then we say the enemy transform.rotation is equal to the look rotation. So that handled getting the enemy to face the player. Now let's get him to move away from the player. So we're going to calculate the distance between the player and the enemy. Now interestingly, normally I'd say we change the position if our distance is less than the threshold, but my research showed that Burst prefers a different way. So we'll calculate our new position, and then use a masked position search. We're going to calculate the distance between the player and the enemy. Now interestingly, normally I'd say we change the position if our distance is less than the threshold, but my research showed that Burst prefers a different way. So we'll calculate our new position, and then use a masked position with math.select, which is cool. You pass in the enemy position, it's a new position, and then an if statement, and it's going to decide whether or not it needs to update, same as our if statement from before, and then adjust the position.
Interesting.
So that's our job struct. Now in update, I don't want that to run until all of our enemies have spawned in. This is just for this example because I'm also using the script to spawn in the 15,000 enemies. So we're going to get a new. Now in update, I don't want that to run until all.
So he's still doing the spawning the same idea. Why is his spawn so much faster though? Or maybe it's not. Oh, you know what? It's probably because we're spawning all in the exact same spot. Let's try and change that, maybe? Wait, what? Where did click to move come from? Okie dokie. What if we give this a random location? Get random spawn location. Random. Vector 3. Public float m radius, spawn radius. Transform position. Wait, this is supposed to be a quaternion? Do, do, do. Get rotation. Get rotation from random spawn location to position PO random spawn location to POI position. Spawn rotation. I wonder if this fixes the problem maybe. Right, I didn't update that. No, I did. What? Oh, it's because my spawn radius is 0 and then we want this to be 20. Much better, so much better. Okay. Yeah. It was totally that main camera. Yeah. Oh, that's why it's pointing in a weird direction. There we go. That's instantly better. Look at that. Okay, so we're at 60 FPS right now, right? With 2000. So 60 FPS is kind of like 2000 is kind of our cap right now. I wonder if we can push this. Can we push this even further? Is the big question here. How much further can this be pushed? It's an interesting question because like hopefully it's a lot, but we need okay, so we have batches. Like we can potentially batch these. But it's hard to say. So make the AI jobs. How's it going? What's up, Chrono? It's going. Check it out. Check it out. Check it out. Oh, 2000. Non-ECS. This is entire mono behavior. 100% mono behaviors. It's pretty intense, the fact that I did this. I think the cooler thing is my friend who has an old ass PC can run this with 1,000. How did you do it? It's the $1 billion question right there, isn't it? So the target PC, right, which is Chris M, right? I don't know if you know of Chris M. So Chris M's a friend of mine, right? Uh, yeah, he has he has the potato. Um, apparently I can't find him. What the fuck? Here we go. Here we go. This is the guy. I want to target this guy's PC, right? So I want to target this guy's PC. Who's a friend of mine, and this is one of his characters that he's working on right now. Anyway, so I want to target his PC because he has the oldest PC out of all of us. I think he's like pre 1080, like pre 10 series NVIDIA, right? It's a really old system, but he can run the this at he can run this at he can run this, I think he said, at 60 FPS. After the old spawner finished spawning everything in, it would run at 60. So he is more GPU bound. Well, everybody's going to be more like no. So it was he was fine. He was fine. So it was the spawning. The spawning would kill my system too, right? If I when I would go to spawn with the old spawning system, it would kill my system as well. So let's put this back to the old spawn system for and then we'll spawn in 2000, right? So here's the new system, right? And then if we do the old system, there, and the old system was just doing this, right? Where this would be transform dot or just transform dot position, just yeah, and then transform dot rotation dot location. Is it location? Oh, position. There we go. And this one's important. There we go. Okay. So this is the old way I was doing it, and this is the way I just changed it to, right? And then if we go here and we want to spawn in 2,000 units, right? So 2,000 pedestrians. There, we're at 2,000 pedestrians, and we hit play. It's going to take a while for all of these to spawn in. Because they're all spawning on top of each other, right? But here we can see my CPU is climbing, right? And my FPS is kind of tanking. No. I wanted them to spawn in all together, like instantly, right? But the issue is that like they were while they were spawning in, right? They're spawning on top of each other, so there's extra compute that needs to happen, right? So if I switch it over to this system here, and now if I want to spawn in 2,000 of them, I hit play and they all just appear because they're not spawning in on top of each other, right? There you go. So this functions super well. I'm really surprised at how well this works, though. So now I will show you how we did it. So, all of these characters are walking around in T-pose. As you can clearly see, they're all T-posing, right? As in, there's 0 bones in this scene, which is really what's giving us our performance here. We're doing vertex animations for all of these. Right? I got it working. I got it working yesterday. I wanted to stream yesterday, but with everything going on, it was a bit hard to. Yeah, it's just colliders moving. Actually, no, she doesn't even have a collider. Well, she has this, right? She has this collider. That's all that's moving. That's going to be the next thing that we do. First things first is I don't like this animation. I don't know about you, but I think this animation looks like shit. It looks really awkward, right? So I think that we should fix that. So we're going to attempt a fix. And with that, we want to add in some extra stuff, right? For like we want to add in extra all the extra stuff. But also, this is the important thing. Look at the batch, the batches. The batches for this are insane. Look at that. 41 batches for this entire scene. Remember what we were at? We were in like the hundreds of thousands, right? At the start. And now we're at I thought we were at like 300,000. But yeah, at any rate, we're now down to 41 for 2,000 units. 41. That is a dramatic drop, right? Oh my God, this is beautiful. Hmm. Here we go. So we can see, if I go like this, we can see the I got it baked in. So she's only one material now. I can't remember if I got that working with you guys or without you guys, but she is now one material, not multiple materials. I had a feeling, but I figured I'd ask anyways. So this is it right here, right? So this one here is the multi-material one. And then we do these steps here and then push it through this baker here. And by the time we get down to this baker, we have one material. And we've deleted the other materials. Then we went to Mixamo, right? And we dropped and here we've got this here. And then this provides the materials here, right? Anyways, so what we've got now is we've got this, right? So one material. And then we come down here and we come into here. And this does the vertex animation walk, right? Cycle baking. So all we have to do is change we can copy this and just change this walking animation to something else and we can get a different vertex animation, right? So if we then look at this one, this is the FBX file here, right? So this is the UV for the color. Then if we look at the UV2, this is the UV for our the beauty that is our animation. So this is our animation UV right here. And this is what gives us the amazing. Yeah. This UV is what we're using for animations. Yeah. And that's how we got it down to 41. But now I want to see if I can replace this animation here, right? So this is our animation here. And if we bring this down to a single UV here, or a single screen here, and we hit play, we can see that this animation doesn't look super great. And I can grab an animation that I really want here. And we're going to see if we can get this animation here to work. Where is her walk animation? Wait, is this it? No. Wait. Yeah, it was this one here. Okay, walk. Okay, so this is the animation that we want to try for, but it's probably not going to work. Very obviously not working, right? I wonder, okay, so if I do this, and then I replace this, yeah, it's still terrible. Okay. So we want to transfer the animation. Transfer Houdini. Transfer animation to rig match pose. Then this goes to constraint mapper, which is map points. Okay, there we go. Why is the head so tall there? That's a weird Okay, interesting. Okay, so head goes to head. Neck to neck. Wait a second. Wait, where were we here? What? That should have interesting. It didn't take. That sucks. But I guess it happens. Whatever. Let's see it. Let's see how well this is going to work, though. We won't worry too much about the hand right this moment. I wanna see if we can get the legs to work and whatnot. Left foot. Did I get the feet wrong here? Oh, I did. Oops. Here we go. I want to say that one. Actually, you know what? It might be. It might be that. I'm not actually entirely sure, to be honest. That's a twist, right? Yeah. Okay. There, and then we go to full body IK. Then that goes into. We bring this here up, and then we do. That goes into here. This goes into here, and then we do this, and we do selected, and then we hit play, and what happens? This is more than 30. How many, what's this look like animation wise? Huh. Is that 20? No, it's not 23. 1.2, 0 to 1.23. Houdini animation data. Find total frames. How to determine what's. Yeah. Yeah. But I need to figure out how many frames this animation is. So our rate is. I don't entirely understand this, to be honest. But if we say end frame of 60 and hit apply, maybe we can see everything here. Close. Come back to here. It's 38. 38. There we go. It's still bad. Okay, so the mapping is off, right? Okay, so right toe. We want to change that to toe base. Okay. Wait, what? Okay, here we go. Let's do this. Toe base to wait, which one is this? This is left toe base to left ball to toe base to right ball. There we go. Sprained ankle. Yeah, it totally looks like sprained ankle, right? What if I do this? Gives me nothing. Absolutely nothing. Okay. Mm-hmm. She's so much taller. But seriously, like, it's so weird. What if we remove all of these? Like, what if I remove this and that, and then we come down here and do this? What does this look like now? I do wonder, like, why is one side a little bit more fucky than the other? Hmm. Yeah, because this animation here actually is kind of nice compared to the one that I've got. But the Mixamo skeleton doesn't work very well for non-Mixamo animations, apparently. Uh Maya transfer rig from one character to another. Uh, I really don't. If you're just gonna do that with the writing, just make it like just make it a write up at that point. If you're encountering a situation which requires you to transfer animation, example copying a pose or segment from one scene to another. No, not one scene to another, one character to another. And it's not the animation so much as the rig I want to transfer. The process you're looking for is called retargeting. Do it would be to characterize both rigs using human IK and use HIK to retarget the animation from one rig to another. Houdini retargeting.
Being here, my name is I'm a character 3D with side effect software, and in today's short masterclass, we'll be having a look at retargeting using the KineFX toolset. Now, this topic has been covered quite a few times in the past by us or other users, and the only real difference that this video will impose on the rest is the fact that we will be, one, of course, using the new Houdini 19.5, which will showcase a few other extra features that we've added. But the most important bit here is that this will be strictly aimed at beginners. So if you haven't opened Houdini before, or you have opened it only a few times, this will be a great video for you to get started because we will go through the actual retargeting workflow step by step. We won't dive into much detail in terms of like the actual intricacies of what's happening under the hood. We'll be strictly looking at nodes, how we can interact with them in order to achieve our goal. And the result of this whole masterclass will be an FPX animation, or rather an FPX character with an some animation retargeted onto it that we can then put into a game engine once it's been looped correctly, so we can set it up for a state machine. So if you're a games person, this could be potentially even more useful for you. But keep in mind though, the workflow is very similar for both film and games, or no matter what other projects you might do. So this will hopefully benefit every beginner out there. That being said, we'll be going relatively quickly through the nodes and only really like take a moment on the ones that require a little bit more explanation. So let's go ahead and jump straight in. So I have here seen that I've already built. I didn't want to like stumble across various like values and stuff like this and tweak them with you. I appreciate your time, so we're gonna make this a little bit more quick with having stuff pre-built. So we have here our first node here called basic retargeting. We can dive right in. And of course, the first thing you want to do when you want to retarget is bring in a character and an animation. So in this case, our character is Capybara here that we've modeled in-house, and an animation of this skeleton, blue skeleton, walking on a beam. Go back to the beginning. These are both FPX files. Do keep in mind that if you have a different file format, you can still bring those in. Most likely, we have support for a bunch of file formats. You can check them up online. Mocap import, a very quick tip for other motion capture file formats. But you can definitely find very easy online what information you might need about what file format you are currently working with. So once we've got our characters imported here and we are happy with them, of course, ideally you would go through and examine them slightly just to make sure that they have no major issues in their skeletal hierarchy or deformations, if you haven't done that already. But there's no problem if you do encounter any issues along the way, because we can always go back and fix that because of the procedural nature of the software. So once we have this stuff imported, the first step we want to do here is to rig match pose, is to want to match the green skeleton that we see on screen to the blue skeleton that we see here, or rather the other way around. The pose of the blue skeleton to the pose of the green skeleton.
Oh, hey Funky, check this out. I want to fix the animation. I don't like this animation, but I got it working. So now I just need to get an animation that I do like working. Yeah. It's 41 draw calls or 41 batches to draw. Can you show me I'm at work? Well, look how many characters there are walking around. Look at all the characters. So many characters. It's running at like 60 FPS right now. Oops. There's 2,000. 2,000 characters. There's 2,000 characters in this scene. Right? They're all walking around and all of that wonderful jazz. Too many characters? What? No. We're at 60, 70 FPS. Too many characters. We're hitting targets. We're hitting targets. I'm sure that we could actually make this more performant if I worked at it. But right now, I wanna change animations because I don't like the animation. Her animation feels off, is all, right? I could make more. I could probably make more. Her animation might work, but it just it feels so off. She feels it could be fine. But it does feel like the animation feels a little off. I could slow down the speed a little bit. I can't tell if she's walking too fast or too slow, to be honest. I feel like she might be going a bit too fast. So I could slow down her movement or speed up the animation. But all in all, I think that she's fairly decent, right? But I'm not that worried about it, to be honest. Mm-hmm. This one here. So can Cam be here lurking? All right. Have a good day at work. Okay, so she's floaty, like as all bloody hell here. Oh wait, is that because of the nav mesh that she's? So she's floaty on the nav mesh. Or does she need to be down further? Minus 1.3. Well, let's see what happens here. Maybe a little bit lower. Oh, that's perfect right there. Look at that. Maybe I should just not worry about it, to be honest. Like, because I think Mixamo has like a bunch of things that we care about anyways. I don't know. I don't really like the Mixamo stuff. But like it's really not that bad. Yeah, it's because they don't have like they don't have a female walk, right? So this is the walking cycle that we've got. Place. Right? And then we brought her arms out a little bit because we didn't want her to. There we go. But the problem is that like it's kind of manly. I wonder actually, what if we do this? Give me a second. Mhm. Oh, retarget test. This is one that we want. We can put the city animation stuff into here and then do the retargeting in here and bring it out, and that'd be worth it potentially. Maybe the answer is don't retarget in fucking Houdini, retarget in Unreal and bring the retargeted stuff into Houdini. Let's try that. That would be cool if you could use Unreal to export a retarget. We're going to try it. We're actually going to try that. Mixamo, sorry. Retarget. We're going to try it. We go. Okay. Content, characters, new folder. Hmm. Oh, that is bad. That is so bad. Okay. Delete all. Yeah, that was definitely a problem right there. Okay, so the problem with that import was that we imported using this, and I think we want 10. There we go. That's almost better, I think. It's not good, but let's take a look. Okay, so if we go to here and we take a mesh for here, we bring this into the world right there. Beautiful. Okay. Now let's bring her into the world. Sumi. She's still small, right? So it's not 10. It's 1,000 that we 100 that we want. There we go. Where is it? Where is it? Where is it? Category. Mm, man, fucking the it's so bad. It's so fucking bad. It's so hard to find stuff now because like nothing really works properly anymore. The new fab system is just bad. City Cinem this one. You in launcher. This is what we want. What are we looking for? City Sim. Add to There we go. Okay, so there she is, and there he is. We now have the animations in here, right? And what we want to do is we want to do a retarget here. Do Unreal Engine retarget animation. Oh, wait. I think I have a Mixamo thing. I thought I had a Fab Mixamo thing. Oops. I thought it was in here. Mixamo. Give me 2 seconds. I'll be right back. Right. Okay. I thought I had a Mixamo thing for the. Oh, thank you for the follow. I thought I had a tool for retargeting, but I guess I didn't. My library. I thought I did. Mixamo? No, I did not. Okay, whatever. Anyways, UE5 Mixamo retarget.
Wait. You're telling me that you're teaching something actually useful in 57 seconds. Yeah. So here's where to get the Mixamo converter from Terabilis Studio. When you download the folder, make sure to unzip it with password Terabilis. You're going to find a folder in that directory that contains mannequin skeletons. You got to upload the skeleton you want to the Mixamo website, and then once you do that, it's going to take a little bit longer than expected. But get your animation that you want, you download that without skin, make sure it's uniform, and once you get that in your downloads folder, you move it right into your incoming FBX folder. You open up the Mixamo converter, and then select again, scroll down, and then you just convert the animations. Go into the outgoing FBX folder, just make sure it converted properly, and once you got that, just drag it in. You need to make sure to select SK mannequin for this, and make sure your settings match mine here, and then import.
Yeah, no, that's not what I wanted. I think it's this.
What's up, guys? Welcome to new Unreal Engine 5 tutorial, and today I'm going to show you how to retarget the Mixamo animations into the epic skeleton, or then into the mannequin, or any other character that you have from the marketplace that uses the epic skeleton, or whatever. It's going to be a very easy video to follow and quick. So I have seen a lot of tutorials out there, and they're a bit confusing because they're like 40 minutes and etc. But today I've made a very easy to follow tutorial to understand what we're doing and how to do it basically in a short amount of time. So with no more said, let's get started. Alright, so first of all, we need our animations from Mixamo. So let's search into mixamo.com. If you don't have an account, go ahead and make one from the wiki. I already have like a character here, but of course I'm going to use another one for the tutorial. So just go up here into characters, and basically we are going to find the what was the Xbot, something like that, Whitebot, whatever you want. Use this character. There we go. Now the character doesn't really matter, okay? Because we are only going to use the animations in this case. Actually, because we're going to use the feminine version of the epic skeleton.
Sup, Don? Wait. Guy, gilded, tuba. What the fuck? What? Why? What the fuck? Oh yeah, Don, check this out. Check this out. Oh yeah, no, totally. Sometimes it's not fast enough. Look at this. Look at this. Right around 60 FPS. 2,000 characters walking around. 60 FPS. It's beautiful.
Because it's by default, I'm going to choose the Xbot. So when you have selected it, you will see that it's using T-pose. Just go up here into download, let it in FBX binary and these T-pose. Go ahead and download it. Alright, so just before importing it.
Do they bump into each other? No. They avoid each other. They have avoidance. Yeah. Like watching ants. Yeah. I probably should bring down their avoidance a little bit because it's a bit too large, I think. But whatever.
I'm just going to create a new folder, which is going to be called Mixamo tutorial, or whatever. And now we can import the character. Just go ahead and drag it into the content browser. Now you'll see that we have all the settings. Just leave them as default. Make sure you have skeleton mesh and import mesh selected, and the skeleton as none. So we'll create a new one. You say import all. We have just warning because of the FBX type, but it's okay. And then there we go. We have all our assets. Now, of course, you create a physics, a different skeleton, 2 animation sequences, whatever. We are only going to use really the skeleton. But anyway, Ctrl Shift save to everything. All right. So now that we have our character, let's get the animation that we want to basically just get from. So let's go up here into animations. Get the butt out. So now just what we have to do is create an IK rig, and then here we're gonna set up all the chain bones that we want to copy the position and then rotation also, and paste it over the mannequin's skeleton to copy basically the animation. You will understand it just much better when we start doing.
Yeah, he's. I feel like this isn't No, that is. Wow. I feel like he's going a bit slow is all. You know what I mean? Oh, look, we got somebody who wants a good old fashioned band here. Here. Oh, I can't remove them from Twitch chat because Twitch chat won't show them to me anymore. Hey Don, if I mod you, can you can you ban that person for me? Because I don't have access to the message on Twitch, so. Yeah, I saw it. Don the developer banned Monolithic, Pucker, whatever their fucking name was. Thank you, man. I appreciate it.
Doing it, I'm gonna use the new chain system from Unreal Engine 5, which is really cool and easy to use. So just right click, go into animation, and then we're gonna create an IK rig. So now here.
Animation. Oh, you know what? I think I have to restart this. Wait, cancel? Import. Wait, one sec. What? Okay, they're all imported already. Going to go eat, get a haircut, have a good stream. All right, thanks, Don. You have a good one too, man.
Here we have to select which skeleton we want to create one from. In our case, it's going to be the Xbot, which is going to be the Mixamo rig. So I'm going to rename this into IK rig underscore Mixamo. We go, save it, and go ahead and open it. Alright, so in here you can see that we have our character with all the bones. We can see also the hierarchy of the bones here, and we have a really cool window that we did this IK retarget. So just select it, and now what we can do is create chains, which basically will go from one bone to another one. So basically this changes from other versions of Unreal Engine. I wouldn't have to go bone by bone, but we can create a whole like change. So for example, from the shoulder to the hand is going to be the left arm or something like that, which is going to be just much easier and faster for us. So there are two ways of doing it. We can go ahead and just add new chain, and then just to show you, the first one is actually going to be head. So just type in head, and then we can select the start bone and the end bone. In the case, the start bone for the chain of head is going to be neck, and then just like neck, and then the end bone is going to be the head, top, end. Okay? Now, that is a way of creating the chain, or a faster, in my opinion, way, is just going up here into the hierarchy, selecting the bones that you want. And so next up is the spine. So select the first spine here, and then shift, select the spine 2, and then right click, and then we can create a new retarded chain from selected bones. And its name is spine. There we go. And it will do exactly.
Okay, so wait. What was that one? That was spine to spine 2. I don't have a spine 2. Huh. Their Mixamo character has different but I think it's bust, right? Or is it upper chest? Wait, does she have boobs? She does have blue boobs. Interesting. I didn't realize that. I totally didn't notice. Neck to head. So it's neck to... Can you change her hair color? I can. I have to do baking though to change hair colors. It's not as easy to... Actually, let's see if this works. Oh well. Okay, it's not as easy to change as you might initially think, right? I don't think this is actually the right one, is it? This might be the right one. Wait, this has the skirt, right? Yeah, this one has the skirt. This is not... Which one was this? Okay, this one's the school. Yeah. But right now we're just trying to get everything worked out, right? Do we have a route? Oh, we don't have a route. Hey, wait. Spine to spine 3. Where's spine 3 look? Okay, so that's gonna go to... a chest? No, it's not chest. There. So this is spine. Add chain. Root is root to root. We don't have a root, so we're gonna skip that one. Neck is neck 1 to neck 2. Neck. Oh no, it's neck 1 to neck 1, right? Neck to head to top of head. I think I imported the wrong character. Yeah, I think this is the wrong character. Neck. Add chain, head. Add chain. Let's do the arm now. So this is clavicle. Okay, so it's shoulder to. Oh wait, no, this to clavicle to. This is left clavicle. It's this one to hand. That's left arm. There we go. Is she backwards? Actually, yeah, no. That's fine. Whatever. Shoulder to shoulder, which is going to be the clavicle. Okay, and then we're going to go to the leg. I don't like the colors here. Okay, that is going to be the I guess the left leg. Add chain. And then we're going to do the right leg. There we go. I think these are backwards, to be honest. Yeah, I think these are actually backwards, but we're just gonna whatever. Mm, this, and then we want. There we go. This is the one that we care about, I think. Let's create a IK. Okay, there we go. And then we'll do this. So root to root. Spine 1 to 3. Clavicle to hand. Oh, wait. This left arm one we've got to redo. Left clavicle is its own thing. Actually, wait. This one I think we can just do the auto create. There we go. There we go. It's all there, but it's not showing up here. I don't know why. I wonder if it's because I need to reopen it, maybe? No, it just doesn't want to. Weird. There we go. Beautiful. Okay, so now that we have these two, we come into here, right? And we do new animation, retarget, IKR. Quinn to Kasumi. Kasumi. Here we go. Preview scene. Oh, it doesn't have her knee. That's why. Oh, interesting. Weird. No, it does. Are they walking together though? Yeah, they are flipped. Right arm. It's all backwards. It's all backwards. Okay, so we save that and we come over here and we hit play. Do-do-do. Girl walk. Okay, so add chain. Oops, cancel. Um, then we want to do, what is it? Neck. Can I show all bones? Oh, there we go. That's that's the top of head essentially. So this would be there's head. So here's neck, add chain, and then add chain. Interesting. It's because of the shoulders, maybe? Okay, then we go back to here. So this would be the clavicle, if I'm not mistaken. Yeah, this is the clavicle. This is the right clavicle. Neck to neck. Head to head. Right clavicle to right clavicle. To left clavicle. Save. It's a little bit better. There's still something going on with the spine. Spine's not quite right. It's because it might be the hips or the arms. It might be the arms that are making it feel weird. Let's fix up the arms here. Left arm to hand. Right arm, add chain. Upper arm. There is no IK though. So these are weird. Why are they up like that? Oh, wait, that's why. Can we auto align? Don't do that. Uh, Interesting. Okay. Beautiful, beautiful, beautiful. Let's bring these back together. How do I do that again? Oh, here we go. Yeah, this, if I bring this back over here like so. Um, there. And then we come over to here and we just do, we do this. $50? Sure. There. And then if we edit retarget, oh, interesting. Okay. I got these backwards. Apparently these want to be the other way. Left, right. Oh, you know what? It's the hips. Um, okay, let's do the leg. Hmm. The knees are fucked. Entirely fucked. Why is this not running? How did you stop? I don't have a root bone, do I? There's my hip. Oh, retarget root. Yeah, okay. Target, I can't. I think this is the wrong character, to be honest. I'm going to close this. Close this one. Oh, it's the single map. That's the one that we want. Oh, that's fucking terrible. Forced delete. That's not what I wanted, but okay. Here we go. I don't want to bring in. Okay, interesting. This is weird. There we go. That's a better skeleton right there. So then if we do, I do this, can I just delete these? Just don't care. There we go. Beautiful. Okay, so if I go like this and we do create, we just want to create a IK from this. Look at that. I think that's literally all of it right there. Beautiful. It just did it for me. Save. Save. Beautiful. Can I just jump to this one? Because I... Is that the right one? No. This one here is the right one. This one. Her hands are a bit fucky. But the rest of her is fine. What if we do this? It's a little bit better. Old dried leaf. Welcome back. Maybe like a little bit more. That looks better. Sweet. It fucking just works. This is great. 10 out of 10. So let's specifically transfer this one over. Idle and walk. Actually, let's just do them one at a time here. So we'll do this one and then we'll do retarget animation. Ooh. Girl walk. Oh, these are sit animations. There we go. Booyah. Her waist swings a bit much, but it's definitely better. Huh. I didn't think about these ones. We could retarget this. I think these are all Tsumi. Yeah, okay. I only fucked up naming. Yeah, I only fucked up naming them here. That's fine. Save all. Doesn't matter. Let's actually see some of these. That seems fine. Okay. So, now what we want to do is we want to export it and see what it looks like inside of Sumi. It's supposed to be Kasumi, not Tasumi. But I don't care enough to actually rename it right now. Girl walk. This one here is the one that we want to export. Export. Well, if we're gonna do this, we might as well export all of these. New folder. All right. And we'll have to pick this up tomorrow since I've got an event coming up and I got to go get ready for it. I will catch you all later. Thank you to everybody who joined in and chatted and lurked and all of that. You were all awesome. I will catch you maybe a little. I'll catch you on Monday. I promise not to miss days to next week. All right. Ta-ta for now.